Hello, in today's daily lead code challenge, the question is number of good paths. So here there is a tree which is connected and undirected graph with no cycles consisting of n nodes, and they are numbered from 0 to n minus 1 and with exactly n minus 1 edges. So each edge has a value I, and we are also given with the edges from AI to BI, so that is undirected in nature. And we are also given a condition of good paths. In the good paths, their starting nodes and ending nodes are same, and all the nodes between are less than the starting and ending points. So it is like we are given a condition that a path is a good path if its a starting and ending point is same, and the nodes which are falling in between that path other than a starting and ending nodes are less than the starting and ending nodes. So we are not concerned with the value and the order of the paths which is being there, but we are also concerned with the values which contain in that path should be smaller than the starting and ending point. So in first example, as we can see, so here the number of good paths are 5 already, because all the nodes it's in itself are good paths. But if we look closely for the second condition there, like all the nodes between a starting and ending point should be smaller. So if we look closely for this 3 or 3 values, so these two nodes 1 and 2 are smaller than 3, and this could be possible solution for that. So I think the answer for this would be 6. Similarly, in the following example, we can verify accordingly that 5 paths are there, and this 1 1 and 2 2 are included into that paths. So the answer is 7 here. And if only one node is present, so our answer will be 1. Also, we can't use any uh, iteration over nodes, and we can't look into the nodes which are possible for that paths, because it would be leading us to the time complexity of big of n square. So we will try doing it by in complexity n. So looking at the current scenario of grouping, I think it will go in the direction of DSU again. And for solving this, I have some picture representation for you. So what we will do here is that we will represent the nodes by circle and the nodes number by a square here. If numbers are here, so what I have done here is that I have calculated the nodes, like the nodes or with the value, like value 1 2 3 are have node, like the nodes which contains value 1 2 or 3. So what I am doing here is that I am activating every node one by one, and then checking whether we can make a path from that or not. So how we are checking? So suppose if I am at any valued node, and the number of nodes containing the same leader, so that can, like, the number of nodes containing the same leader is x, then the number of paths which are good in that is xc2. I hope you are getting my approach, that if we are writing nodes in this manner, these all are sorted, and if we are going into the increasing order, that would be our solution. So in the first iteration, when 0 and 3 becomes active, so I am like marking that active node by this value, by this picture. So here 1 and 3, 0 or 3 nodes are active here, but we can't merge them because they are like being active at the same time. Okay, and none of the nodes, other nodes, are active at that time. So we are marking that as active, and the leader of 0 and 3 would be 0 or 3 itself. So the number of distinct paths here, we can't find any paths because we can't join it, and also that's not a good path. So going further, if we join 2 into the path and make the leader as 0, so here it will add 0 into our result, because the path is not possible here, if we can see. like value 1, 2 and 1, it will not satisfy the second condition, that is the path in between doesn't contain any like it can't contain any value node which is greater than the starting and ending. So if we join 3 here, so here what we can see that the valued 3 have leader 1 and 4, and if we combine them, so all of them becomes a part of one component, then now finally their leader would be 0, right? And if we calculate the leader by the formula of xe2, so the answer would be 1. So it will add up to our answer 5 plus 1 equal to 6. So I hope you approach my approach, like understand my approach. Let's try to code this question in C++. So first we will make a structure DSU, and then we will use that DSU into our approach. So let's try to code it, and then we will submit it. In DSU we have a parent and the size array, and we find the parents and size, merge them accordingly. So for understanding that, if you need any another video to like explanation of DSU, you can comment down below. I will make another video about it. So let's code this DSU first. What we had done is that we will find that parent of two nodes, and if they are equal, there is no need of merging. If they are not, we will merge that. So it's complete. Let's make that nodes array. Then we will do our iteration over all the possible conditions. So let's do it. Like count of node paths in initially would be n, because all of the nodes is a part of good path. So we will count them initially itself, and we will iterate over the nodes value, like value map to that nodes, and then we will iterate over them. Then we will count the leader and find whether all of the groups are same, like all of the nodes which have the same leader, and count the possible good paths contained in that component. So let's do that. And our answer will be count into count minus 1 by 2, that is NCR. Then we will return our answer. I hope it will run. Let's try to run this. So I forgot to say one thing. So all the test cases are passing. Let's try to submit it. So it got accepted. So this is the solution for today's daily Leetcode challenge question. So I hope you like the video. Thank you for watching.